And there we go.
Just in time.
Video 3.
We're going to cover our two acid-base theories,
Yes, there are two.
explain the basic, pun intended, nature of acids and bases.
Sure. So
So,
first off, what exactly is an acid?
well, there are compounds that react with water to produce an acidic solution. pH lower than 7.
Yes.
pH lower than 7. What's a base?
There you go. But any compound that reacts with water to produce a basic solution
pH.
of greater than 7.
There you go.
Higher.
So what does that really mean? How does this actually happen?
Well, here we go. Then.
First
Let's get
theory.
into it.
Svante Arrhenius, Swedish chemist.
Oh, look at you. Yeah.
Sorry, I remember many things. These are acids that are compounds.
Got a lot in there.
Yeah, got a lot of info in there. They release H plus protons, hydrogen ion, or AKA hydronium ion,
Same thing.
as the only positive ion solution. That's
Right off
really from our definition.
Right off of our vocab.
So we'll show you what this means in a minute.
Right.
In a
And
picture.
then right off the vocab, bases are compounds that release OH minus hydroxide ions as the only negative ion in solution.
For sure.
And then here we go.
This is what it looks like. So if you take a compound that releases H plus, that H plus goes into the water
That's here.
right there, and it's charged positive. And the water molecule has extra electrons up there because it's polar, and it attracts that positive charge, and they kind of snap onto each other.
So let's say it was right there.
Yeah, and it creates a different molecule that carries a
It does.
charge. It's actually a charged molecule. That water, H hydronium, that positive proton will pop on and off of the water
Yeah.
molecule as it needs be.
Yeah.
So that's the action of
Here's a
forming
good spot. I didn't
H2O+.
write this on here yet, but you're listening and not bumping. You can take a side note. Ready? This is called a coordinate covalent bond.
That is
We
true.
didn't do that in bonding, so here's
No.
a good spot. Now that we see what it is, that's what it is.
Cool. So let's see what else we got to say about Arrhenius theory. Here's the formation of the acid again when it's not a particle model. So this is HCl, hydrogen chloride, the stomach acid, reacts with the water that it comes into contact with. That H jumps off the HCl and hops onto the H2O,
Making the hydronium
hydronium
ion.
leaving the chloride ion as the negative ion solution. So
But
you
the
see
only
there's
positive one is hydronium.
H plus, and there's no other no other negative ions in solution. So that's why this called an acid.
There you go. And then so the same thing's kind of going to happen for a base. I got this sodium hydroxide. It's going to, I don't see the water, but water is happening. It's going to dissociate straight up into NH pluses and OH minuses in solution.
And if that OH minus steals a proton from water,
Then it leaves
Becomes
water as an
H2O.
OH minus. So that
it just-
cycle is going to never end. It's going to always have OH minus in solution.
and that's why that's a base.
There you go. So problems.
So not what if there's a molecule out there that doesn't have OH on it, but it's still
a
basic.
base. That's basically the issue, basically.
Ha, puns. Because it's true. Some things out there do test as bases, but they don't have any obvious hydroxide part
Yeah.
of their molecule.
I'm going to switch this next year, but how about the general rules for Arrhenius anyways?
Yeah.
So before we move on, generally Arrhenius produce OH plus
Recap.
ions as the only solution. There's the only positive ion in solution. And just for naming sake, H is usually the first element in the chemical formula for most acids.
Right.
Helps us pick them out.
Recap the bases. They produce hydroxide. OH negative is the only negative ion solution, and typically their compounds have OH at the end of their formula.
Perfect.
But again, what the problem is, some of these things test as bases and they don't have an obvious OH.
Right, but they're still in our little common acids and bases, so that helps. So the alternate theory comes into play to help explain this compound like NH3, because some of these compounds do not obviously contain an H plus or an OH ion in them and to dissociate directly. When they do dissociate, though, they mess with water and produce it indirectly.
Right.
Now we need this alternate
So
theory.
Bronsted-Lowry acid is really any compound that is able to donate a hydrogen ion or a proton to a water molecule, or any other molecule for that matter,
making it.
making it H3O plus or allowing the other molecule to accept
Sure.
that proton.
If that H plus is just floating around in solution, or it hooks up with the water and forms H3O plus,
Or if it hooks
same
up
deal.
onto the other molecule and forms some other
It's still
ion.
going to dissociate
Same
back
deal.
off. And
Any compound that's an acid gives away H plus
Sure.
to somebody else.
And this part of the definition doesn't deviate much from Arrhenius.
No. But this part does.
This part does. So now any compound is able to accept an H plus ion that has been donated. Now I am a base.
Right. So you don't have to have OH in your formula to be considered a base. As
No.
long as you're soaking up the hydrogen ion that another molecule
Right.
gave, you're considered
And
a
that works
base.
with the old OH theory or the old Arrhenius theory, because that OH that came off soaks up that H plus
from another
making,
water
making it
molecule.
an acceptor of H plus.
So it's kind of convoluted, but it's really kind of simple too.
It is, but okay.
This
Here's
is
a
a great picture. Love it. This is that ammonia molecule, the important one,
Right, so that's
that
here.
is a base, but it doesn't have OH in it.
No, he wants this hydrogen.
There's
atom.
a water molecule nearby. And that ammonia is so polar that it steals the hydrogen atom off the water molecule, creating a coordinate covalent bond that Mr. Milks mentioned a little while ago. And since it stole the H plus from the water, it leaves water as OH negative, the base.
Yeah.
Which then
Here's that
is
OH
what
negative.
the pH probe or the tester is saying, hey, that's basic.
Right, because there's no H plus ions in here competing with it.
Right. So
That ammonium ion now has got it locked up. It's a polyatomic. It doesn't lose it very easily now.
right. And that's how a molecule that doesn't have OH in it can be considered a base. Because
There you
it messes with water, donates or accepts a proton.
So there you go. Recap. NH3 accepts an H plus ion from a water molecule, creating a leftover OH minus in the water in the process. So now this OH ion is created indirectly, not directly. I didn't just dissociate it out of me.
Right.
Cool.
That's why
I
it's
think
an
that just
alternate
about
theory.
covers it.
Probably.
For some examples.
Let's do some examples. So,
Oh,
table
your
K,
turn.
common acids.
All right.
I want you to notice something really simple, kiddos.
Yeah, dude, look at what they all start with, guys. They all start with H. So in that recap of Arrhenius, that most of them start with H, most of them do.
There's two exceptions.
Right. The Ku is the exception. It ends in an OH, and you think that it might be a base, but it's not. And then look at their names. They all end in acid. So that's part of the naming structure. Ic acid or us acid. We don't have to really do too much to figure out which was which anymore. It used to be a thing in the day, back in the day. Ic versus us. I know it's saying, but where am I going to teach to you? Because it doesn't matter anymore.
Acids are obvious.
Says acid.
And there's a whole table K for you. We don't throw ones that don't show up on here.
That's the other cool part. The acids that we're going to deal with are going to be on this chart, period. If they're not on this chart, they're not going to give them to you.
Or we feel like challenging you.
And here's the deal. If they're not on this chart, guess what? They're probably on that
that
chart.
chart because they're not acids, they're bases.
They're
Which
bases.
is-
And
check it out.
we said most of them end in OH. They name their names end in hydroxide for that very OH. And the special one is that ammonia, which we decided needed the alternate theory. So now we have an alternate theory to name and call all of these things bases. We have 4 bases to deal with for the whole unit, basically. So not too bad. I think I use lithium hydroxide sometimes,
Yeah, but it's the same.
just for fun, but you won't get it too much as far as a Regents question.
Yeah, and ammonia, again, alternate theory is a base because it's a proton acceptor.
There you
Hydrogen
Ooh,
ion
check it.
acceptor.
That's it. We done.
See?
Stop the recording.